Hello, my name is Danny Arribas-Bel and I'm a senior lecturer at the University of Liverpool in England, as well as a Turing Fellow at the Alan Turing Institute in London. Today I'm going to talk to you about urban sustainable development and artificial intelligence, and in particular how the two intersect and how I think there is a lot of potential for the combination of the two. But before I get going, I wanted to send a note of congratulations to the organization for being able to hold this forum, which is a fantastic opportunity, and also to thank the organizers for inviting me to speak at the forum. So what do I want to do and what do I want to cover today? I'm going to start talking a little bit about something that I call urban analytics and defining it, covering a little bit why it is and why I think it's important, particularly as we're talking about sustainable cities and the use of artificial intelligence. And then I'm going to cover two examples of recent research that I've been involved that I think exemplify very well how artificial intelligence can be applied for the idea of urban sustainability or more sustainable cities, and what are the potential opportunities that I think through collaboration and innovation can be deployed in urban contexts. So let's talk a little bit about urban analytics first. What do I mean by urban analytics? Well, the background here, and I probably don't need to convince anyone in this room, is that we're being flooded more and more by data every day, and we are generating at this point more data than we can analyze manually. So as a response to that, the industry a few years ago created the field of data science, and more recently the extension of geographic data science, which is the intersection of data science with geography and geographic data. And many people see this idea of data science as the data refinery, the domain that is able to take the amount of data that are being generated and convert it into insights and actionable decisions. A lot of that, really, when we're talking about data science, and in particular in the context of cities, a lot of the promises that I see for data science and artificial intelligence in urban context is this idea of obtaining more and better measurement of phenomena that we might be interested in understanding better, but also in applying or in modifying through urban policy. Sorry. So in many ways, this idea of data science and data or new forms of data, as we're talking about in this context, is akin, and some people have already, before me, have already made this comparison, is akin to the microscope to biology when it was invented. It was a tool that it allowed scientists, and to some extent in the context of cities, to understand their object of study, cities for ourselves, at much more finer granularity. Okay, and I think this creates immense opportunities that require analysis, innovation, and collaboration, but that can really radically change how we manage cities and how we make them more sustainable. So that's the background, the idea of urban analytics and techniques that are able to apply artificial intelligence in urban context for better sustainability and more sustainable futures. Let me tell you about a couple of examples, so two examples of recent research that I've been involved that operationalizes these ideas. The first one is a project that I was fortunate to be involved a couple of years ago, or a bit more recently actually, and it's about measuring urban green coverage in urban environments at the street level. So what's the background here? The idea is that urban green space has been proven to be very valuable for many aspects. A lot of them cover the idea of public health, physical health, so people can go and exercise, but also mental health and other benefits. There's a wide literature that proves that green spaces in cities are a good idea. However, we know very little about how much green space our cities have. And if we don't know how much our cities have of green space, it's hard to plan for good policies. And in addition, measuring green space turns out to be very expensive or very difficult or both. right? So if we could come up with ways of better quantifying and creating better measurements of urban spacing, of urban green spaces, you would expect policymakers to be able to take advantage of these better measurements and then make better decisions. So what did we do in this project? There's a lot of information in this slide, but I'm gonna try to walk you through a little bit. So the input data that we took was street level imagery, so photos taken by cars or pedestrians or cyclists at the street level. And this is the key thing, that we were able to take images taken at the eyesight level. And we had a lot of them. In our example, all of this is published, and if you're interested, there's a paper available. But just to give you the quick preview, we had a lot of photographs for a British city, for Cardiff in this example, and they were taking snapshots at for several streets throughout the city. So what we did was feed in this data. At the end of the day, images are a data set. So we fed these images to a convolutional neural network that is able to parse, as we call it in the machine learning jargon, to parse the image and extract different areas, and not only parse it and extract it, but also label them, which is very important. So the computer was able to do by itself entirely the operation of identifying different regions of the image that were covering different elements, and then categorizing them into different groups. One of them was vegetation. So what we did was taking the areas of the image that were covered by vegetation, or that our algorithm was telling us that was covered by vegetation, and then we created a score for that. And then through this is what we would call pixel classification. We were able to say for every pixel in every image what was represented in the photograph. And then once we have a score at the image level, what we did was applying some sophisticated statistical modeling to aggregate at an area that is useful for policymakers. So creating scores at the image level is interesting, but is not necessarily very useful for policymakers who are working on policies that are applied to regions or to neighborhoods. So what we did was applying some statistical methodologies to aggregate smartly those individual scores into a small area or a neighborhood score, and then that created the map that you can see on the right hand side of the slide. So what's the relevance, or what's the usefulness of this application? Well, as I just said, having a sense of how much urban green space a city has is important for crafting and shaping policy, but measuring green space is very difficult, or at least very expensive, because you will have to deploy large amounts of coders, of population that would have to go around walking and recording the information. What we're doing in this context is replacing that human, that expensive effort to collect the data by an algorithm that is automated and that uses artificial intelligence to be able to parse through photographs that have been crowdsourced and extract a score for the amount of vegetation that every street has. So the idea of this is that we can now then scale it up, scale the analysis, because scaling it once you have the computer recognize a vegetation from images, it's very cheap to scale and to redeploy it at a much larger scale, and it's also very fast. So what we've created is a methodology to create automated, scalable and timely indicators of urban vegetation that rely entirely on artificial intelligence. And that was one example at street level, and then I wanted to tell you a little bit about a second example of another project that I was involved that also includes imagery. I think imagery is one of the most interesting data sets that are becoming available and that are subject to being used with artificial intelligence. So I want to tell you about an example that I worked on with some colleagues from Colombia. and that was published in the journal PLOS ONE. So the idea of this paper relies on two key hypotheses. The first one is that the physical appearance of a human settlement is a reflection of the society and the people who live there. So what our cities look like, and particularly what our cities look like from above, from the sky, is a reflection of the society that inhabits those cities and that at some point created, and it's constantly actually creating and reshaping urban environments. So that's the first hypothesis. The second one is this idea that urban areas that look similar from the sky can be assumed to be inhabited by similar populations. And this is more of a, some people see this as a slightly more strong assumption, but ultimately we treat this as an empirical assumption that we then subject to our analysis. And what we find is that to a great degree, this is actually true. What the type of, different neighborhoods that look different usually tend to have different people or different types of people living in that area, and areas that look similar, that have similar patterns as you look at them from a satellite imagery, can also be seen to have similar populations. So if we can assume these two statements, then the idea of the project was to extract, and again, not completely unlike in the previous example, extract measures or quantitative descriptions of areas, of neighborhoods, based on what they look like from the sky. And again, here there's a lot of machine learning and there's a lot of artificial intelligence involved in converting unstructured information in the form of pixels and colors into structured information, or in other words, in the particular example that we were working with in this project, we were trying to come up with a score of deprivation, a measure of a general measure of poverty for a neighborhood, only with the information extracted from the satellite image. So what we did was coming up with several scores that capture the structure, the texture, the spectral and the color characteristics of an image, and that by putting them together and feeding them to an artificial intelligence algorithm, we're able to identify areas with higher deprivation, higher poverty, or lower poverty. And again, if you're interested, the paper is open access and is published in PLOS ONE, so you're most welcome to check it out. But the gist that I would take from that is this is the area where we applied it. This is the city of Liverpool, where I'm based in the northwest of England. And what you're seeing in the slide now is the distribution of values of the official statistic that we were trying to predict with our satellite methodology. And what you're seeing now appear right next to that map is the map that our algorithm generated, the predictions that our artificial intelligence approach generated from only satellite imagery, right? And of course, it's not perfect, it's not exactly the same values, but you can see how it picks up the vast majority of the structure and in a way is identifying the main patterns as to how poverty and deprivation is distributed spatially. So why do I like this example? Why do I think it's a good illustration of how artificial intelligence can be used in the context of urban environments? Well, because again, same as in the previous example, generating these official statistics is very expensive and also takes a long time. So the refresh rate between one official publication of the indicators and the next one is fairly long. It's usually 5 to 7 years in the particular case of the score that we were trying to predict. But with satellite images, satellites are orbiting the Earth already. They're collecting data more and more frequently, and in particular with the imagery that we have available today, you could calculate similar scores every 2 weeks, which is a lot more frequent than in the original one. So again, if we can combine new forms of data with artificial intelligence and machine learning, we can create scalable and much cheaper ways of generating at least intercensal. We're not necessarily suggesting that we would replace completely traditional statistics, but it's more a story of collaboration and generating, through innovation, generating more and better measurements, better metrics about cities. So instead of having one official statistic every 5 years, maybe we can have one every 5 years, but then every year or every half a year have a refresh based on satellite imagery. And the idea is that if we can have more timely information about the distribution and about the changes of poverty or other social phenomena, we can make better decisions about it. So these were the two examples that I wanted to share with you today, and I want to conclude by sharing a few thoughts around this idea of sustainable urban environments and artificial intelligence. The first one is that for everyone working in cities today, we need to realize that the landscape is completely different. We have a lot more data, and that the problem is not finding data, is being able to process the large amounts of data that we have. And that in itself, I think, creates a great opportunity for making our urban environments and our cities more sustainable. But the main challenge of this context, as I was saying, is not finding the right data, is being able to process and making and creating insights from data. And for that, what I think is critical is the use of AI, machine learning, and of course cooperation and innovation between different communities, and academic and in industry as well. So that's everything I wanted to share with you today. Thank you very much for the opportunity, and congratulations again to the organization for being able to hold this forum. Thank you very much for your attention.